Okay, so I'm going to make a quick video about MilliEquivalents, mainly because the first time around that I heard about them in our lecture, I was completely clueless, completely lost. Don't even remember exactly when I learned them, but now I can do the problems. Just went back to take a look at my notes on them, and I really didn't understand the basics of what was happening behind the scenes. And so I'm glad I did, and thought I would share my aha moments in case there's other people who needed some aha moments. Okay, so a quick, I guess a quick definition, if you will. The milli, or the equivalent, is the weight of a substance that combines with or replaces 1 gram atomic weight of hydrogen. Okay, so to me, that still doesn't solve it for me. But I then turned the page and I realized that we're talking about electrical activity of the ions in solution, and specifically looking at the valence. We know we're supposed to be looking at valence, and we're looking at, here's another thing that I didn't catch the first time around, either positive or negative. So when we're looking at the calcium chloride here, we are looking at just that positive section or the negative section. So that was something else that bypassed me the first time around. Now, I do recall this table, and he gave us a list, I believe, of 7, and I only wrote down 6 and carbon, and I just don't see where carbon fits in here. So if you know what that 7th one is after this, let me know, please. I did find it interesting that most of what he told us to know were also electrolytes found in the blood. Though I knew that kind of. It's nice to know that. So anyhow, we need to know ammonium and chloride and potassium and sodium. We need to know those all have a valence of 1. And then we need to know that calcium and magnesium have a valence of 2. And you can see that I also did kind of highlight, I did highlight the phosphate and the sulfate. They have valences of 2 because those were anions found in the blood as well. But we're going to be able to find that information from our cations anyways. So one of the things that I did to learn this was every time I saw a problem that had valences with it, I wrote this whole list down so that I could start to remember. It's not going to do me any good if I get into an exam and I know that there's a valence problem, but lo and behold, I can't remember what that valence number was. So I'm going to write it down each time I do a problem. That's the same page as last time. Here are just some example problems on how to find that out. Now remember, we are looking for positive or negative. Of course, to me it's just easier to find your cations rather than your anions because they're anions because they're first. But here we have the positive. Oops. We have the positive. Why aren't you writing? Okay. My device isn't writing, and I'm not sure why. Okay, there we go. Sorry about that. Okay, so we have the positive and the negative. And we know, let's go ahead and rewrite that list. I said I was going to do that every time. We have ammonium and chloride and potassium and sodium. Those are all going to be a valence of 1. And then I remember too that calcium and magnesium had a valence of 2. And also, if you were to think on the periodic chart, you're going to find these ones on your first column and the calcium and magnesium on the second column. So that's also going to help you remember the valence numbers on these. Okay, so moving back to sodium acetate, of course, this is going to be my positive, this is my negative, and a sodium is 1. We have sodium phosphate diabasic down here. This is my positive, that's my negative. I need to notice that there are 2 of these. That means that my valence will be 2. And this problem right here, or this particular spot right here, threw me for a loop in the lecture. Had no idea what was going on at that point. I'm glad I finally figured that out. Thanks, Nelson. Appreciate that. Okay, so anyhow, then I also have the calcium carbonate. We have as a positive and a negative. And calcium, we saw, has a valence of 2. So those were practice problems there. MilliEquivalents is going to be equal to millimoles times the valence. And make that smaller, just easier to write with. Here's a question: when are the numeric values of milliequivalents and millimoles similar? And that's going to be when the valence is equal to 1. That makes sense, right? MilliEquivalents, millimoles times 1, anything times 1 is itself. Silly, but there it is. Okay, MilliEquivalents is equal to the weight in milligrams times the valence over your molecular weight. And of course, that's going to be in grams per mole. And I guess just an extra thing here, the equivalence. This is not the milliequivalents. The equivalence is going to be that weight in grams. So we're going to be using that to backtrack and find weight and stuff here in the future. So, okay, that's it for now. We're just going to go ahead and move on into some practice problems.